Okay, so chapter 9. So before we look at the questions, let us do a quick revisions, okay, on what is a simple harmonic motions. Wait, yeah. All right. So what is a simple harmonic motion? So we have a SHM. First of all, we need to know what does it mean by simple harmonic motions? What types of motions? Okay, we treat it as a simple harmonic motions. So first of all, okay, it is a well, we are going to check the relationship between A and X. So if A is directly proportional to negative X, then it is most likely, okay, a simple harmonic motions. The object is moving with a simple harmonic motions. And another things that we can say is about simple harmonic motion, it is a periodic motions. Okay, so what does it mean by a periodic type motions? Well, object keep moving back and forth, right? It keeps oscillating. So from a positive amplitude to negative amplitude, and then goes back to positive amplitude, goes back to negative amplitude, and it keeps going on. So that is what we call periodic motions. So in this case, okay, based on the motions that we obtain, it's going to give us a graph. Okay, a graph like this. So it start, it move, and then it oscillate. So it start from a, let's say, equilibrium positions, and then it goes up to the positive amplitude, right? And then it goes to the negative amplitude. And then it keeps repeating the motion. So this is our simple harmonic motion. So our x against t graph. So based on this graph, we can then form an equations called x equals to a sine omega t and then plus phi. So this is our general equations. Now, what is it so important about this equation? The first thing that you have to know is this whole thing, omega t plus phi, this part we call it phase angle. Okay, this part is known as a phase angle. And then sometimes the questions won't ask for the phase angle. Question will just ask for initial phase angle. So which part of the equations represents initial phase angle, which is the phi. All right, so this is our initial phase angle. Okay, initial phase angle. So what is the difference between phase angles and initial phase angle? Initial phase angle, it tells us where does it start from. Okay, it start from origin, equilibrium positions, or it start from maximum amplitude, or anywhere in between them. All right, that is our initial phase angle. It refers to the starting point. Whereas for phase angles, it refers to the positions of the object after a certain amount of time. Maybe after 1 second, maybe after 2 seconds. So that is our phase angle. So it is a slight difference. Okay, there is a slight difference between phase angle and initial phase angle. So make sure you know what is the difference between them. And the question is asking for which variables. Okay, now when it comes to these equations, okay, so how are we going to form equations based on the graph given? So we have x against t graph. Based on the graph given, we can obtain the values of a, and then we can also obtain the value of period, which is the time taken to complete one oscillation. Okay, time taken to complete one oscillations. That one we call it period. Why is it so important to know the values of period? Okay, to get the values of period from the graph. Well, because in chapter 9, there's one thing which is very important and that you need to understand, you need to remember, is that T, omega, and frequency, they are one family. If you are given the values of period, then you can calculate omega. Okay, if you are given the values of a frequency, you can also determine the values of omega. All right, and if you are given T, then you can calculate F. So T and omega, okay, omega is equals to 2 pi over T. And then how about F? So if you are given frequency, then we say omega is equals to 2 pi F, or F equals to 2 pi over omega. Whereas for a T and frequency, their relationship is T is equals to 1 over F. So they are one family. If you are given one of the value, then you will be able to determine the other two value. right? The value for the other two quantity. Okay, now let's go back to the equations. Equations, we have x equals to a sine omega t plus phi. This equation is very important. Quite often, questions will give you graph, and then it asks you to form an equations. Or even if you are not given a graph, you are given a few informations, and questions like to ask you to determine to form the equation based on the informations given, based on the situations given. How? How should we construct the equation based on the informations given? So first of all, you have to understand this equation. Okay, x equals to a sine omega t plus phi. So what is x? X is the displacement from equilibrium position. And then what is a? A is the amplitude, which is the maximum displacement from equilibrium position. And then omega is the angular velocity. T is the time. Okay, small letter t and capital letter T, they are not the same. So capital letter T is the time taken for one oscillation. Small letter t, it could be at any position. And then phi is initial phase angle. So if you look at this equation, there are three terms that is fixed, that won't change throughout the motion if there's no external force that is being acted on the object. So which is A, well, the maximum displacement is always the same, right? The maximum displacement, which is the amplitude, is constant throughout the motion if there's no external force acting on the object. And then, well, if object is moving with the same frequency, okay, then it will have the same omega. So omega is also constant if there's no external force acting on it. It will keep moving at a constant angular speed. Okay, and then initial phase angle, of course, is fixed. Well, because you have only one position, okay, one point. So these three quantity, they are constant, which means you can sub the value into the equations if the question asks you to form an equations. Whereas x and t, they are not constant. Okay, they are not constant. So which means you have to leave it as unknown in your equations. Why? Because x changes with time. Okay, x changes with time. For different time, okay, the object will travels at will be located at a different displacement. So let's look at the graph. Let's say at times t equals to 1. So at times t equals to 1, your object is at its amplitude, for example. Okay, so maybe at a times t equals to 4. Okay, let's say or 3.5. So as time t equals to 3.5, your object is somewhere in between maximum positions and equilibrium position. So x keep changes with time. Okay, at different times, you will have different x. So this is your x1, this is your x2. Let's say if you have a times located at here, this is your t3, then you will have x3. So displacement changes with time. Therefore, you don't know what is the value. Okay, so when you construct the equations, you leave x and small letter t as unknown. And then you sub the values of a, amplitude, omega, which is the angular speed, and initial phase angle into the equation. Then that would be our final equations. Okay, that would be our final equations. So now let's see. Okay, let's see how are we going to solve the questions now. Okay, before that, I give you 2 minutes to write down some of the summary. If there's anything that you're still confused, you still don't understand, then you may ask. Okay, bagi kamu sikit masa untuk catat summary. So this is a quick revision. Okay, on the things that you need to know about simple harmonic motions, how to use its equations, how to transform from graph into equations. Okay, from graph and equations, and how to construct equations. So 2 minutes for you to write down the summary. If you have any questions, you may ask. Okay. So it's very simple. Now let's see. Let's try the questions. Okay, questions 1. Let me change the color first. Questions 1. Okay, exercise 1. Questions 1. The expressions for the displacement x of an object undergoing linear simple harmonic motion is given by these equations. X equals to 3.5 sine 8 pi t plus 0.25 pi. Now, whenever you are given an equations like this, what you can do, you compare with what we call general equations. So what is a general equations? Now, for displacement, the general equation is just x equals to a sine omega t plus phi. Okay, so this is our general equations. Now, sometimes questions will give you equations in terms of cos. So if you're given cos, then the general equations, you just simply change it into cos. Okay, since now you're given sine, so you keep the equations in terms of sine. Okay, you keep it in sine form. So if you're given cos, then you just write a cos omega t plus phi. Where x and t, they are measured in cm and in second. So it tells you the unit, okay, the unit for x and also the unit for t. Now, why is it important to know the unit for x and t? Because amplitude will use the same unit. It will have the same unit as your displacement x. Okay, so x and a, both of them, they uses the same unit. So if x is in terms of a cm, then a is also in terms of cm. And then second is for time. Okay, so if your time is in terms of second, then your omega will be in terms of radian per second. If time is in terms of minute, then your omega should be in radian per minute. All right, so it is quite important for you to check the unit before you solve the question. Make sure you know what is the units that is being used in the questions. So x is in cm and t is in second, respectively. Determines the amplitude, the periods, the frequency of the oscillation. So three things. You need to determine amplitude, period, and frequency. So how are we going to solve it? Of course, by comparison. So you compare the equations given with the general equations. So by comparisons, you obtain A, it is equal to 3.5 cm. Okay, 3.5 cm. And then by comparisons, you have omega equals to 8 pi radian per second. But now, question is asking for period and frequency. So what are we going to do? Remember, omega, period, frequency, they are one family. If you have omega, then you will be able to determine period and also frequency. So omega is equals to 2 pi over t. So plug in the value. Okay, you will obtain t is equals to 0.25 second. And then omega at the same time is equals to 2 pi f. So rearrange the equations, f would be 4 hertz. So that is how you solve the question, right? That is how you solve the questions. You try to identify the informations given first. How? By comparison. So by comparisons, you obtain A, you obtain omega, and you even have the initial phase angle. All right, but since the question is not asking for initial phase angle, so just leave it. All right. So now let's look at questions 2. Questions 2 is asking for phase angle. Okay, not initial phase angle, but phase angle. So which means the question is asking for this whole part. Okay, the whole thing, omega t plus phi. Okay, so we have 8 pi t plus 0.25 pi. So at times t equals to 0.02 second. So phase angles given is equals to 8 pi t plus 0.25 pi. So given times t is equals to 0.02 second, what are you going to do? Well, just plug in the value. So it is equals to 8 pi 0.02 plus 0.25 pi, which is then equals to 0.41 pi radian. Okay, 0.41 pi radian. Question C. The displacement at an instant mentioned above. So which means it is asking for displacement at t equals to 0.02 second. So what are you going to do? Well, you just plug in the value as usual. Okay, you have equations already. Your equation is x equals to 3.5 sine 8 pi t plus 0.25 pi. So 8 pi, substitute t as 0.02. So plus 0.25 pi. So it is equals to 3.4 cm. Okay, 3.4 cm. Now, when it comes to these questions, chapter 9, make sure your calculator is in mode radian. Okay, because you see the phase angle, the units given is in terms of radian. So your calculator should be in mode radian if you want to calculate the displacement, velocity, and acceleration. Okay, so we are done with questions 1. Now I give you 2 minutes to write it down. Okay, 2 minutes to write it down, the important informations that you have in the questions 1 before we proceed to second questions. If you are done, you may try second question first. Okay, so let's move on. Okay, to questions number 2. Questions number 2. What is the equation describing the motion of a mass on the end of a vertical spring, which is stretched 8.8 cm from equilibrium position and then released from rest? So how are we going to solve these questions? First of all, we need a diagram. So this is the initial positions of your object. Okay, so this is the initial position. So what happened now is you stretch the spring. Okay, you stretch the spring. So now your object, okay, your object is located 8.8 cm below equilibrium position. Aha, it's important. Why? You'll find out soon. Okay, now, what will it, what will its displacement after 1.8 seconds? So first of all, it's asking for equation. What is the equation? So which means it wants you to form equations. Now, to form equations, you need to know the uh, positions of the object. Okay, you need to know the positions of the object. Where is it? At times t equals to 0. So according to the informations given, okay, at times t equals to 0, your x is below the object. Okay, your x is below the object. So what are we going to do? We have at t equals to 0 second, x is equals to negative 8.8 cm. All right, so this is the information that we have. So now we want to form equations, but before we form equations, of course, we need to know the initial phase angle first. So let's begin with general equations. X equals to a sine omega t plus phi. Okay, so this is our general equations. So we have a times t equals to 0, and now we have x equals to negative 8.88 cm. But then how about our a? Well, you stretch the object to 8.8 cm and you release it from that. The point where you release the object, that is our amplitude. Okay, that is our amplitude. So which means amplitude given is also 8.8 cm. Okay, amplitude given is 8.8 cm. And then how about the omega? You're given period t, which means you can calculate omega. So omega equals to 2 pi over t. Okay, which is equals to 2 pi over 0.66 second. Then you're going to obtain 3 pi radian per second. Okay, 3 pi radian per second. So now our next task would be determining the initial phase angle. So this is the step that are often overlooked by the students. Okay, they always forgot about this step. They forgot about initial phase angle. Now you need to always remember there is an initial phase angle in our questions. Okay, so x equals to a sine omega t plus phi. X at times t equals to 0 is negative 8.8 equals to 8.8 sine omega t, well, 3 pi times 0 plus phi. So rearrange the equations. Okay, rearrange the equations. If you solve everything's correct, okay, if you solve everything in the correct manner, then you will get phi is equals to negative pi over 2. Right? Phi is equals to negative pi over 2. So that is our initial phase angle. So once you obtain initial phase angle, okay, you can then proceed to forming, say, complete equations. So this is how you determine, okay, determine initial phase angle. All right, so this step is very important. All right, students always forget about this step. So now we have it, we can then proceed to forming a complete equation. So x is equals to a is 8.8, sine omega is 3 pi, so 3 pi t plus, okay, initial phase angle is a negative value, so I should use minus pi over 2. Okay, minus pi over 2. So that is how we form equations. So this is the equations that we're going to use in solving the questions. So what will be its displacement after 1.8 second? So at t equals to 1.8 second, oops. Okay, at t equals to 1.8 second, so x is equals to 8.8 sine 3 pi 1.8 minus pi over 2, okay, which is then equals to 2.72 cm. Okay, so this is the final answer. Okay, this is the final answer. So you start from a sketching. Okay, why sketching is important? Because it tells you now your x is equals to a negative value. It is located below initial position. So the displacement is a negative value, right? The displacement is a negative value. Now, sometimes students, they try to sketch a graph, okay, based on the diagrams sketch. Okay, we know that our objects start from negative amplitude. So the graph will look like this. So this is your x against t graph. So since your objects start from negative amplitude, therefore it's going to be look like this. Okay, so sometimes students straight away determining the equation, forming the equations based on this graph. Also can. Okay, also can. So this is your A. So you have an inverted cos graph. Therefore, your general equation is x equals to negative A cos omega t. Also can. Okay, it's nothing wrong. So you have two ways. Okay, you have two ways in the determining the equations. All right, but the one, okay, the one that I showed you in the blue color, you determine the initial phase angle first. That is a more proper method, more proper ways in solving the questions. Okay, so kadang-kala pelajar dia akan sketch graph dulu berdasarkan makluman yang diberi. Boleh juga, okay, kalau sketch graph, kamu dapat graph bentuk cos terbalik, so terus kamu tahu equation dia is x equals to negative a cos omega t. So dari sana anda boleh terus buat, tak ada masalah. Okay, just as sometimes initial phase angle is not located at amplitude, then you need to use the one in blue color to solve it. Okay, the one in the calculations, the method to solve it. So kadang-kala kamu tidak diberi lokasi initial phase angle. Dia cuma beritahu kamu, okay, 3 cm, 4 cm. It doesn't tell you whether it's amplitude or not. It doesn't tell you whether it's equilibrium position or not. So in that case, okay, we must solve it by using calculation. We need to calculate the initial phase angle first. Okay, so cara pengiraan yang guna warna biru ini, dia adalah cara yang lebih tepat sebenarnya. Okay, kaedah yang lebih tepat. So it's up to you which one you want to use. All right. In physics, there's no definite answer. As long as you got the right idea, you got the right concept, then it will be accepted in your exam. Okay, so ada dua cara untuk kamu buat. Kamu boleh form equations dengan dua kaedah berlainan, and then bila buat pengiraan, tetap akan dapat jawapan yang sama. Okay, so 2 minutes for you to write it down again before we move on to the next question. Okay, 2 minit bagi anda catat sebelum kita bergerak ke soalan seterusnya. Okay, kalau ada apa-apa tak faham, kena tanya ya. Sebab kita sekarang masih dekat asas simple harmonic motions by just looking at the equations only. All right. Questions number 3. Questions number 3. A particles undergo simple harmonic motions along a straight line, completing 20 cycles in 2 seconds. So this statement is very important. Why? Well, it tells you about cycle. 20 cycles in 2 seconds, which means you can use these informations to calculate period. Okay, so 20 cycles in 2 seconds. Then 1 cycle equals to how many seconds? So you use, let's see, equals to 20 cycle. Oops. Now you want to find out the times per cycle. Okay. So 20 cycles in 2 seconds. Let's see. T equals to, okay, it's 2 seconds. So 1 cycle is equals to how many seconds? So x equals to 2 divided by 20. All right, 2 divided by 20. So which is then equals to 2 divided by 20. Where is my calculator? It's a 0.1. Okay, 0.1 second. So that is the period. Okay, that is the information that you can obtain based on the statement given. 20 cycles in 2 seconds. So 1 cycle is how many seconds? It's 0.1 second. So from here, you obtain the amplitude. Now, why is it important to obtain amplitude? Again, remember we have T, F, and omega. They are one family. Okay. So the amplitude of the motion, you have A is equals to 3 cm. At times T equals to 0, the particle is at its equilibrium position. So this statement, again, is very important. It tells you where is your object at times T equals to 0. Okay, so at times t equals to 0, if it is at equilibrium, mean x equals to 0. Okay, at t equals to 0, x is equals to 0. So displacement to the right of O is considered to be positive. Write down an expression, so which means it's asking for equations, representing the displacement of particles. So we're going to start from a general equation. So general equation, x is equals to a sine omega t plus phi, right? So we have a equals to 3 cm, and then our omega is equals to 2 pi over t, which is then equals to 2 pi divided by 0.1. This then equals to 20 pi radian per second. So when you have omega and you have a, we can then proceed to calculate the initial phase angle. So what we know is, okay, let me change the color first. So this is how we determine initial phase angle. So at t equals to 0, x also equals to 0. That is based on the statements that I highlight in the questions, right? So now I'm going to sub everything into my general equations here, okay, into these general equations. So x0 equals to 3 sine 20 pi times 0 plus phi. So rearrange the equations for these questions. I got phi equals to 0 radian. So I know that now the initial phase angle is equals to 0. So when I try to form equations, I can then ignore the initial phase angle. All right. So from here, I then form a general equations. X is equals to 3 sine 20, oops, too far away. Okay, 3 sine 20 pi t. So that is my answer. Okay, that is my answer for questions A. So because my initial phase angle is equal to 0, I don't have to include it in the equation. So this is the answer. Questions B. Okay, now let's move to questions B. So questions B, determine the displacement of the particles at times t equals to 1 over 16 second. So at times t equals to 1 over 16 second, it's very simple. Basically, you just plug in the value. So x is equals to 3 sine 20 pi times 1 over 16. Therefore, x is equals to a negative 2.1 cm. That's it. So when you have equations, okay, when you already form the equations, when you already have the equations, and the question asks you to determine the displacement at a given time, basically you just have to plug in the value. Okay, basically you just have to plug in the value. Okay, so now let's look at how to solve question C. Determine the time when the particle is at x equals to positive 1.5 cm. Now, if you remember, okay, what we say is about a simple harmonic motion, it is a periodic motion, which means the object, it will pass us through x equals to 1.5 cm multiple times. So you will have more than one answer, all right? Not just one answer, but you have more than one answer. So now let's see how are we going to solve question C. Okay, so question C is a bit long. So question C, well, we have general equations x equals to 3 sine 20 pi t. According to the questions, now your x, okay, your x is equals to, so when x is equals to positive 1.5 cm, so what are we going to do? We sub the value into the equations. So 1.5 equals to 3 sine 20 pi t. Okay, 3 sine 20 pi t. Rearrange the equations. I have sine 20 pi t equals to 0.5. Okay, equals to 0.5. So 20 pi t is then equals to sine negative 1, 0.5. And this one, it will give you more than one answer. It is equals to 30 degree, And then 150 degree, 390 degree, and so on. Okay, and so on. So how do I know it's a 30 degree, 150 degree, and then jump to a 390 degree? If you recall, when you have a positive sign value, okay, so when the value is equal to a positive value, so the angles would be located in the first and the second quadrant. So
Okay.
positive sign, negative sign, negative sign. So first and the second quadrant. So 30 degree in the first quadrant, 30 degree above x-axis in the second quadrant, that is a positive sign value. So 20 pi t equals to sine negative 1, 0.5. So after first and second quadrant, it rotates, it goes back to the first quadrant. So 30 plus 360 is 390. And then the other side, 150 plus 360, you will get the following value. All right, you will get the following value, and so on. So usually we just show the first three is enough. Unless the question is asking for more than three. Okay, then you might have to show the fourth, the fifth value, and so on. Okay, so now that you have it in terms of a degree, okay, or if you use a mode radian straight away, you should get it in terms of radian, if I'm not mistaken. Okay, so if you use a calculator in mode radian, this one at the same time is actually equals to pi over 6 radian, or 5 pi over 6 radian, or 13 pi over 6 radian, and so on. Okay, so then you can solve it. So the time is then equals to 1 over 120 second, and then 5 over 120 second, and then a 13 over 120 second, and so on. Right? So x, okay, x is equals to 1.5 cm at this given time. 1 over 120 second, 5 over 120 second, 13 over 120 second, and so on. Right? It keeps going on until the end. Okay, until the oscillation stop. So this is how we solve it. Okay, this is how we solve it. So you will have more than one answer. Usually if the question doesn't state, usually we just give one answer. But you have to look at the marks allocated to the given question. If you have a one short questions and then it give you 5 marks, for example, then definitely it's asking for more than one answer. All right. And sometimes questions will ask you, okay, state the three given times when the x is equals to plus 1.5 cm. Then you know you need to give 3t, okay, 3 different t. So it's all depends on the questions. So usually if the questions didn't say anything, for example, like this question, okay, sometimes we just give one answer is enough, right? Sometimes we give one answer is enough. Just that I shows you the possibility. If the question is asking for more than one answer, how are you going to determine the following time? Okay, the following time. The second times when the object is located at 1.5 cm, the third times when the object is located at 1.5 cm, and so on. Alright? So, saya tunjuk kamu kemungkinan. Okay, so soalan ini dia tak sebut. So, kalau dia tak sebut, biasanya kita anggap dia minta satu masa sahaja. Kadang-kadang soalan akan sebut, okay, kamu tentukan masa, 3 masa, di mana X sama dengan 1.5. So, Anda kena tahu cara dia. So, macam mana cara dia? Saya dah tunjuk kamu dalam soalan C. Okay, itulah cara kita tentukan masa untuk objek berada di 1.5 cm. Okay, so it's a periodic motions. Dia asyik oscillate. So, dia akan berada di 1.5 cm banyak kali. Okay, bukan sekali saja. So, you can determine quite a lot of times given. Right? So this question is slightly more complicated. I give you 3 minutes to solve it. Okay, to write it down. So we'll continue again at a 3:05. Okay, take a short break also. So 3 minit bagi kamu catat, and then kita ambil short break 5 minit sebelum kita sambung ke soalan seterusnya. Okay, so you write it down. Make sure you understand the questions.
Medium. Oh, medium. 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 Hello.
Hello?
Medium yang last sekali tu T tu.
Aha.
Kalau saya buat dua saja tak apa ke? Contohlah kalau memang kadang-kadang saya buat dua je.
Kalau soalan dia tak minta, actually satu dah cukup. Okay, cuma kadang-kadang soalan dia akan sebut dekat sana, dia minta anda tulis dua masa ketika objek kamu berada di 1.5. Dan okay lah dua cukup. Kadang-kadang dia akan minta tiga, dia akan minta empat. I rasa dia macam pernah minta up to lima. Okay, dia
Oh,
minta lima masa apabila objek kamu berada di 1.5 cm. So anda kena sambung lah. Dia terpulang pada soalan.
okay.
Okay, so I hope you guys are still with me. Right. So well, you guys can actually get a coffee first because
Yes.
after the next questions, we will be looking at derivations of a sixth equation if I'm not mistaken. Okay,
Wow.
so habis sikit dah minuman kamu kak tak apa. Yes, Akil, any questions?
Oh, saya masih berada di sini.
Bagus, masih berada di sini. Okay, so kita tengok sikit satu soalan lagi and then kita akan bergerak ke derivations. So kalau nak, anda boleh ambil sikit makanan ke, minuman ke untuk teman anda waktu kita buat derivation. Okay, now let's look at the questions 4. Okay, the last question in exercise 1. Actually, questions 5, same as the questions 3. Okay, questions 5, I will just skip it. You can try it as a exercise. See whether you understand questions 3 or not. Okay, it's same as the questions 3. Dia ada sikit mistake dekat sana. 3 and 5 soalan yang sama. Okay, now let's look at the last questions in exercise 1. Okay, a variable force acting on an object of mass 0.15 kg. So you are given M causes the object undergo simple harmonic motion. Figure shows the force varies with displacement x of the object for each cycles of oscillation. Determine the amplitude and the frequency. So you are given a graph like this. It's asking for amplitude and also frequency. Let, let, let us determine the amplitude first. So what does it mean by amplitude? Amplitude means maximum displacement. Okay, maximum displacement. So if you look at the graph given, it gives you F against X, force against displacement. Aha. So you have displacement right now, which is the x-axis. Now you look at the value. On the positive x-axis, you have the value 0.02. On the negative x-axis, you have the value 0.2. Which one is larger? Obviously, the one on the negative side, which means now your A, the amplitude is 0.2 meter. Okay, we go for the one with a larger value. Why? Because amplitude means maximum displacement. When you have two choices, 0.02 and 0.2, of course, we go for the larger value because that would be our maximum displacement. That is our maximum displacement. Okay, so amplitude is equals to 0.2 meter, and then determines the frequency. So how to determine frequency? Now you're given force and x. So let's see. How are we going to determine the value? Force, we know what? Okay, we know force is equals to ma. Okay, that is according to Newton's second law. Now we can solve it because according to the definitions of a simple harmonic motion, okay, A at the same time is equals to negative omega square x. So now we can have a omega in our equations. We managed to plug in omega in our equations. Now, when you have omega, then we can find f because remember omega, f, and t, they are one family. So f equals to negative m omega square x. Okay, now our next questions would be, which values are we going to use? So if you look at the graph, okay, when x is equal to 0.02, we don't have the information about the force. Okay, we don't know what is the force at x equals to 0.02. But what we do know is when your x is located at negative 0.2, the force is 3 Newton. So that is the information that we can get from the graph given. Okay, we can extract from the graph given. So when force equals to 3 Newton, okay, so 3 equals to negative m, given m is 0.15 kg, and then the omega square times the x, which is negative 0.2. Okay, negative 0.2. So rearrange the equations. Omega is then equals to 1 point, not 1.6, sorry, is equals to a square root 100. Okay, square root 100. So square root 100. Now, how are we going to calculate the frequency? Omega at the same time is equals to 2 pi f. So rearrange the equations. F is equals to square root 100 divided by to pi. Okay, so therefore it is equals to 1.6 hertz. Okay, 1.6 hertz. So that is the answer for questions 4. So from F equals to MA, we plug in A equals to negative omega square X. Okay, because we want to find frequency. So if you want to calculate frequency, then you need one of the member from this family. Okay, from this family. So either omega, either F, and either T. So we know A is equals to negative omega square X based on the definitions of simple harmonic motions in your lecture notes. So F is then equals to negative M omega square X. Plug in the value and then solve the questions. Eventually, you'll obtain F equals to 1.6 hertz. All right, so we are done. Okay, we're done with exercise 1. So I give you 1 minute to write it down before we proceed to the next sections. Okay, derivations. All right, let us proceed to the next one. So questions 5, I will skip it because the same as the questions 3. You can do it as a revision. But I think the answer here is wrong. Okay, the answer for question C is wrong. So don't look at this answer. Okay, now we're going to focus on the derivations. So just now we were talking about where is the object at a given time. Okay, so that means we have a x with time. Okay, we want to calculate the x with times in its equations. So actually there's one more relations that we're going to look at in this subtopic. So if you look at velocity, there are 2 columns here. One is the one is the relationship with time. Okay, one is the relationship with time. So the equations with time. Another one is the equations with displacement. Okay, the relation with displacement. So we have 2 types of relations here. So see whether you are given times in the questions or you are given displacement in the questions. If you are given times, then we use the equations with t. If you are given displacement, okay, for example, it asks you to determine the velocity at the displacement x equals to 5 cm. Then you need to use the equations with displacement in it, right? So first of all, okay, from the definitions of the instantaneous velocity, v is equals to dx over dt. So you differentiate sign. Now, this is the things that you have to be careful, okay? Here, this question, okay, we differentiate sign, we obtain cos. That is because you are given x equals to a sine omega t. There's one more possibility in your questions. Sometimes questions will give you x in terms of cos. It will give you x is a cos omega t. So if you are given x in terms of cos, when you differentiate it, v equals to d over dt, you are going to differentiate cos rather than sine. Okay, cos omega t. Now, this is the part that you have to be careful. If you want to differentiate sine, okay, if you differentiate sine, then it will give you cos. But when you differentiate cos, it will give you negative sine, right? So which means you will have a different equations here. So let us go back to the table. V equals to d over dt a sine omega t. You take a out because a has nothing to do with time. Okay, you want to differentiate with respect to time. A has nothing to do with time, so you take it out first. So v equals to a d over dt sine omega t. Differentiate sine, it gives you omega cos omega t. Therefore, you have v equals to a omega cos omega t. So at maximum value, we assume cos omega t is equals to 1. Therefore, V max is equals to A omega. If you are given x in terms of cos, okay, let us look at the equations on the right-hand side. X equals to A cos omega t. V is then equals to d over dt, A cos omega t. Again, you want to differentiate with respect to time. Therefore, we can take A out first because A has nothing to do with time. So d over dt cos omega t. Differentiate cos, it will give you negative sign. Okay, therefore you have A negative omega sine omega t. This is if you are given equations in terms of cos for a displacement. Okay, if your displacement is in terms of cos, then this is how you solve it. Therefore, V is then equals to negative A omega sine omega t. Right? So always be careful with the first equations given. Okay, see whether you are given x in terms of sine or x in terms of cos. So you will have a different v because you differentiate different trigo function. So this is for a relation with time. Okay, so how do I know that this is a relation with time? Because if you look at the equations, I have t in my equations. Okay, I have t in my equations. So this is the equations with time. Now, how about equations with a displacement? So first of all, we have general equations v equals to a omega cos omega t. Okay, this is our general equations. So rearrange the equations. Cos omega t equals to v over a omega. So this is the first equations that I want to use in my derivations. Now you want to look at the relationship between v and displacement. So obviously the second equations that we're going to look at is x. So the general equations for x is equals to a sine omega t. So again, I'm going to rearrange it to get sine omega t equals to x over a. This is my second equation. Now, how am I going to link these two equations together? I have equations 1 in terms of cos, I have equations 2 in terms of sine. So, well, if you try to recall things that you learn in a trigo identity, okay, cos and sine, we can join them by using this relationship. Cos square theta plus sine square theta equals to 1. This is the best equations to use to join these two equations together, to link them together, okay, so that they can be combined into one equations. So cos square omega theta in our case here is actually cos square omega t plus sine square omega t equals to 1. Cos square omega t I have here v over a omega square plus x over a square equals to 1. Okay. So what am I going to do next? I'm going to rearrange the equation. So how? Okay, let's see. I have a v over a omega square equals to 1 minus x squared over a squared. Okay, and then I'm going to expand the equations. Okay, I'm going to move the square. So v over a omega is then equals to square root. Okay, square root 1 minus x squared a squared. So when it comes to a square root, remember it is a plus minus value. Okay, plus minus value. Okay, and then I'm going to rearrange the equations. Okay, so I want to rearrange the equation. So V is equals to plus minus A omega square root 1 minus x squared over A squared. Now I have A inside square root and A outside square root. So what am I going to do? I'm going to move this A. Okay, I want to move this A into square root. So how? Okay, so V is then equals to plus minus omega square root A square. Okay, so 1 minus x square over A square. Right, I'm going to multiply it into the equations. Therefore, V is then equals to plus minus omega square root A square minus x square. So this is the answer. Oops. So this is the equations. Okay, this is the equations for V with relations. Okay, a relations. Okay, V with relation with a displacement. The relationship between V and x. So now I know this is relation with displacement. Why? Because I have displacement in my equation. So just now I have t in my equation. Now I have x in my equations. So if you are given displacement in the questions and it asks you to calculate velocity, this is the equations that you need to use. Okay, that you should use. So v equals to plus minus omega square root a square minus x square. So make sure you know how to well, actually I would say make sure you know the final equations only. All right. So the derivations, it's seldom being asked. Okay, it is seldom being asked in the exam. I think so far it just came out once in the past year questions. Okay, so the most important thing is you know the final equations. And what does it mean by relation with displacement? So V relation with displacement is the equations with a displacement in it. Okay, the equations with displacement in it. So a relation with time means you have times in the equations. Okay, so this one, I give you 3 minutes to write it down. Okay, 3 minutes to write it down. The more important one would be relation with time because you yourself need to know how to do the differentiations in exam. Okay, that one will comes out more often than questions that ask you to derive relation with displacement. Okay, biasanya dia akan suruh kamu derive V dalam trigo punya functions. Okay, dia bagi kamu X dalam sin ke, X dalam cos ke, dia suruh kamu cari V. So you need to know how to differentiate for the relation with time. Okay, untuk relation with displacement, dia macam tak pernah keluar lagi, minta kamu derive equations dia. So you just have to know. Okay, you just have to know how to derive it. Most important thing is you know the final equations. How to use final equations. So you have omega, you have a, and you have x in the equations. All right. So I give you now is 322. I give you 3 minutes to write it down. Okay, we'll continue again at 3:25. 25 past 3.
Madam,
Yep.
dalam banyak-banyak equation ni, yang mana
Uh-huh.
yang ada dalam kertas exam? So
Yang
macam yang
mana yang ada dalam kertas
ah,
exam? Kamu kena rujuk kepada list of formula dalam kamu punya fee board.
formula. Okay.
Fee board sudah ada bagi kamu kan? Kalau tak silap saya, yang dalam kotak-kotak ini semua macam ada dibagi. Macam ada dibagi.
Oh, okay.
Okay, so done. All right. So this okay, actually this is the most complicated derivation for velocity. The rest is very simple. Okay, so ini saja yang dia ambil masa sikit untuk faham sebab dia paling rumit. Yang lain semua actually senang saja. Okay, just that you have to remember relation with time and relation with displacement. So biasanya saya panggil dia equation with time and equations with displacement lah. Saya tak panggil dia relation, saya panggil dia equation. Sebab senang sikit saya nak ingat. Okay, so equations with time bermaksud ada time di dalam dia. Equation with displacement bermaksud ada displacement di dalam equations dia. Okay, next we are going to look at accelerations. So from the definitions of instantaneous accelerations, again, we want to derive accelerations. But how to derive accelerations? A equals to dv over dt. So A is equals to d over dt, A omega cos omega t. Differentiate cos, like I told you just now, you will get negative sign. Okay, so A omega, you can take it out first because it has nothing to do with time right now. So what we want to see is t, okay, it's the cos omega t because you have a t in the equations. So we differentiate with respect to time, d over dt cos omega t, you obtain negative omega sine omega t. Okay, that's why final equations we have omega square here. Because if you differentiate cos omega t, you get negative omega sine omega t. So the maximum accelerations happens, okay, we assume when sine omega t is equals to -1, therefore A max is equals to A omega square. So this is the maximum value. So now this one is if you are given V in terms of cost, okay, this question, this derivations is assume V is in terms of cost. So A omega cos omega t. What if you have V in terms of sine, like the one that I show you just now? Okay, so in the previous example, okay, we derive and we obtain V equals to negative A omega sine omega t. Okay, so this is based on the derivation just now here. So let us continue from here. So now we have V equals to negative A sine omega t. So we want to differentiate it. So A is equals to d over dt negative A omega sine omega t. Right? So negative A omega has nothing to do with the time right now because we want to differentiate with respect to time. So we can take it out first. So negative A omega d over dt. Okay, you differentiate sine right now. Sine omega t. So differentiate sine, you are going to obtain cos. Right? So you have negative A omega. Differentiate sine, you obtain omega cos omega t. Therefore, why am I having two negative here? Should be just one negative, right? So final answer would be negative A omega square cos omega t, right? So you still have a negative sign here, okay? So A is equals to negative A omega square cos omega t. So if you have a V in terms of cos, then your A would be in terms of sine, right? So that is the difference between cos and sine. Depends on the equations given or the equations that you form. So if you form the equations x in terms of sine, then you follow the derivations in the table. Then if you are given an equations in terms of cos, then you follow the one that I show you on the right hand side. Okay, I show you on the right hand side. So it depends on your first equation. See whether your x is in terms of sine or in terms of cos. Okay, now let us go back to the equations with displacement. So equations with times we are done. Basically, we just differentiate the trigo function. Then we will have a t in our equations. How about equations with displacement? So again, we have a general equations A is equals to negative A omega square sine omega t. So if you have a in terms of sine, okay, then I'm going to rearrange it first. Sine omega t is then equals to negative A over A omega square. So this is my first equations. Okay, this is my first equations. So I have x equals to A sine omega t. So rearrange the equations. Sine omega t is then equals to x over a. Okay, so if you look at both of them, equations 1 and equations 2, both of them, they are sine omega t. So basically you can just equal them. So negative a over a omega square is equals to x over a. So rearrange the equations, you have a equals to negative omega square x. So this is basically the definitions that we have seen in the lecture notes, where a simple harmonic motions, the a is always inversely proportional to x, and most often we use a is equals to negative omega square x. All right. So this is derivations for accelerations. Okay, accelerations with time, with displacement. Sorry. Okay, accelerations with displacement. So again, if you look at equations with time, you have t in the equations. Equations with displacement, you have x in the equations. A. So that is the derivations for A. Very simple. Okay, very simple. Now sometimes people will just substitute x, the whole x, into the equations of A. Why? Because if you look at the equations, A is equals to A omega square sine omega t. You have A here, you have sine omega t here. Okay, so basically you just rearrange the equations. Let's show you. Okay, if you rearrange the equations, A is actually equals to negative omega square a sine omega t. So we know that this whole thing is equals to x. Therefore, a straight away equals to negative omega square x. Okay, ini cara yang lebih senang untuk derive. So, cara yang lebih proper dalam table, cara yang shortcut dalam warna hijau ini. So, I give you 2 minutes to write it down, okay, before we proceed to next derivations. Right, so A, the derivation is very simple. And again, as usual, the most important thing is you know how to do differentiations, because you will be asked to differentiate quite often in your final exam. So kalau ada mana-mana bahagian tak faham, kena tanya. Okay, so next we're almost done. Okay, we got 3 more equation, which is a very simple only. Okay, let's see. All right, now potentials energy. So consider, okay, now, yeah. Okay, so if you look at the header, now the columns on the left hand side is equations with displacement. Okay, that terbalik dengan table di atas. So this one is with displacement right now, and this one is with time. So equations that you have right now is the one with displacement. So consider the oscillations of a spring as a simple harmonic motion. Hence, the potential energy for the spring is given by U equals to 1 over 2 kx. And K is equals to m omega square in chapter 9. Okay, so U equals to 1 over 2 m omega square x square. And then so K is equals to m omega square. Okay, m omega square. Now, how are we going to form an equations with time then? So you try to look at these equations. U equals to 1 over 2 m omega square x square. Okay, which part can be transformed into equations with t? Obviously, it's the x. Okay, so we have U equals to 1 over 2 m omega. Oops, won't come out. Uh, okay, so m omega square x square, and then we know x is equals to a sine omega t. So this is a general equations. So basically, you just sub it into the equation. Then that would be the equations for potential energy with time. Okay. So you plug it into the equations. So we have U equals to 1 over 2 m omega square a sine omega t squared. So if you square this whole thing, okay, you will obtain U equals to 1 over 2 m omega square a square sine square omega t. Okay, so this is the potential energy with time. This is the equations. So for energy, basically it's very simple. You just substitute x with a sine omega t. Then that is the equations with time. So for kinetic energy, the kinetic energy of a simple harmonic motions is given by, okay, k equals to 1 over 2 mv square. And now we know v is equals to omega square root a square minus x square. So you plug it into the equations, you got the equations with displacement. Now, how about equations with time? Well, again, we're going to begin with the equations for kinetic energy. So K is equals to 1 over 2 mv squared. And the general equations for V is V equals to A omega cos omega t. Okay, A omega cos omega t. Plug it into the equations. K is equals to 1 over 2 m bracket A omega cos omega t. You close the bracket and then you square it. So basically you just square every terms in the bracket. So K is then equals to 1 over 2 m omega square A square cos square omega t. So that is the equations of a potential kinetic energy in terms of a time, okay? Equations with time. So done, very simple. Okay, for U and for K, it's very simple. Basically, you just use the general equations that you have learned in chapter 5, and then you plug in the equations of X with times and V with time. Then you will obtain the K and U in terms of time, okay, with time. All right, I give you 2 minutes to write it down before we move on to the last equations, okay, the final equations. The final equations, I think you don't even have to derive, right? Yeah, you don't have to derive. So 2 minutes for you to go through to write down the equations, and then we will go through the total energy, and after that I will give you a summary table. Okay, so you write down the summary table, then basically that is the end of today's class. Okay. So the last one, total energy. So total energy is very simple, okay, because if you look at the conservations of energy, what does it mean? It tells us what? It tells us the total energy in an oscillation is always constant. Now, how do I know that the energy is conserved? Well, because for example, now if you release a pendulum, okay, if you release it at this height, as long as the pendulum, okay, after it oscillates for one oscillation, it goes back to the same height, then we know there's no loss in energy. Okay, energy is being conserved. So in this case, we can say E is equals to K plus U, and it is always equals to a constant value. So when we talk about conservation, we always need to mention constant in our equation. Okay, otherwise it's not conserved. So same things happens in your assignment. Okay, if you want to use the principle of conservation of angular momentum, then make sure you mention the terms constant in your explanation. All right. So the total energy of a body in a simple harmonic motion is the sum of its kinetic energy and its potential energy. So if the energy is conserved, then we say the total of K plus U is equals to constant. So it means there's no loss in energy. So the equations of a simple harmonic motions, if you add them up, okay, if you use a 1 over 2m omega square, a square minus x square plus 1 over 2m omega square x square, eventually you will obtain an equations E equals to 1 over 2m omega square a square. Now, if you notice, okay, this equation, it doesn't depends on time, and also it doesn't depends on the displacement. So the equation is a fixed value, okay, it's always constant. So it doesn't matter where is your object, the total energy is always the same. Okay, it's constant. It doesn't matter whether your object is at its highest position or is at its lowest position. E is the same. So E is equals to 1 over 2m omega square a square. And then we know that again, K is equals to m omega square. So E can also be written as 1 over 2 Ka square. Okay, 1 over 2 Ka square. Done. Okay, so that marks the ends for today's class. And now I will show you a summary table. Okay, you just write it down. Because I think your books, okay, they didn't give you this a summary table. So, yeah. Okay. Oops. Okay. So you write down this summary table. So you have the equations with time, equations with x. So basically it sums up the things that we learned today. Okay, you have a x, v, okay, a, k, u, e. So these are the 6 quantities that we learned today. We also learn how to derive the equations for every single variable. Okay, so I give you, and actually I don't need to give you times. Okay, you just write it down. Once you are done, you may leave the class. That's all for today. Okay, kamu catat, and then kalau dah siap, boleh keluar kelas.